Hello, everyone. We will start in a few seconds with today's Carbon Credit Info series number 5 on direct air capture. Let's give a few more seconds for people to join. In the meantime, there's always the chat to ask questions. You can also write in the chat if you already know something around direct air capture, if you know anything around carbon credits in general or other project types. Always happy to hear what's also on your mind. And then we'll get going in a few seconds. Hey, everyone. Perfect. Let's maybe start with the very basic of today. I hope also my video is coming through any second. So today we will discuss the topic around direct air capture. Direct air capture is a carbon removal project type, which is relatively novel. I think around 5 to 10 years old as technology, and it's being built up right now, and more companies are coming to the market. So I thought it's worth to create a event around this. Let me quickly check. I think my camera is not coming through. I hope audio is coming through. Let me just restart this. Can you hear me in the chat? Is my audio working? I hope it is. Let me just quickly continue for now. So today we'll discuss direct air capture as mentioned, and let's directly dive into the technology, what it does and how it works. Can hear but not see. Thanks very much for the feedback. Let me try to reset the webcam in the meantime. But I want to go through direct air capture as an entire project type with you today. What you see here is a simple schematic of direct air capture, and I'll explain all the elements as well. On the one side, what you see in the center is the direct air capture machine. The machine is in the blue box. What it does, it takes in ambient air, so the atmospheric air, and it, in very simple terms, separates the CO2 from the existing air. How does it do it? For that to work, we need a lot of heat. And this heat can either be generated through electricity, through renewable energy, or as we see on this image on the left side, you see industrial heat. So there's an industrial facility, and the yellow pipe shows you low-grade heat, which cannot be used in the industry. So it's kind of a waste heat. But if we transfer this into a direct air capture machine, we can use this existing heat to then separate the CO2 from the air. In the machine, what you will find as well, you see that there are chemical filters, so to say. It looks like a big filter, like a sponge, where this air goes through, and it's called a solid or liquid sorbent. And so to say, it absorbs the CO2 and catches it. There are different ways to do this. There are synthetic ones, but there's also natural sorbents out there. And ideally, of course, we try to optimize to use more and more natural sorbents, which are non-toxic and are not harming the environment. So now we separated the CO2 from the air. We let the normal air go back out into the atmosphere, and the highly concentrated CO2, we use a pipe to pump it underground. And there's different ways to do this. I want to show one of the optimal ways to do it is if we combine the CO2 with normal water and then pump it underground into a rock formation, which is made of magnesium rock. In this case, we label it as basaltic rock, but there's also other types. Then the gas plus the water plus the magnesium creates a reaction and the CO2 turns from a gas into a solid form. So basically, we now changed the state of the gas, and it's solid, and it cannot go up again because of gravity, of course. It's held down. So these rock formations, they are available all around the world. We have them in the US, we have them in Europe and in Asia. And if we do it like this, it's mineralized the CO2, and therefore it's a mineral now and cannot escape anymore. So this is one of the most promising ones, and I want to show you also a second version or a few more ways to store the CO2, because there's quite a few technologies out there these days. We have saline aquifers. So these are rock formations where you can put salt water in. You find them deep underground. Then a second one is the depleted oil and gas fields. It's quite ironic that we can use depleted gas fields and pump CO2 back in them. The good thing about these is that the humans have, of course, investigated these gas fields quite deeply when we extracted the gas. So there's already commercial setup around pipelines and pumps and monitoring systems, and we can put the CO2 back into these. That's actually where the gas has been for centuries or even for millions of years. So it's also a safe deposit. The third one is the one I just mentioned in the graph earlier, the mineralization. And the third one is something to be very cautious about. In some states in the US, for example, in Texas, we see that CO2 is pumped underground to actually enhance crude oil recovery. So therefore, they use the CO2 to pump oil back up. We tried to warn people around this one as much as possible to, of course, not create here conflicts of interest around climate warming and climate cooling. But these are the most common types. Maybe I'll quickly open up for questions if there's any questions right now. So in summary, the technology bit is a big part. The second thing is the energy, as mentioned earlier. You need to control. And then the third thing is the storage. So if you have great technology, easy access heat, and ample storage, then you have a very great direct air capture project. Now a lot of people are asking around, what does that mean in real life? Is this technology ready already? Can we use it? Are carbon credits coming out of it? And I want to give a bit of a perspective on the next page, where we show indicative volumes and price points. So what we see that direct air capture is a technology that is going to scale quite nicely, but this will take still quite a few years. So 2028, 2030 are the first few years where we see real volumes coming to the market, and hopefully after that, more and more. Why is this the case? Is because of the trifecta that I just mentioned. You need to have the tech, the energy, and the storage ready, and there's a lot of work to set all of this up, and therefore this is taking a lot of time to set up. But once it is in place, you have a fantastic project where you can remove millions of tons of CO2. On the right side, we see a few of the price points. So I think the current market average and transactions are being made at 700 euros per credit or 700 euros per ton. On Freeze Carbon, we have projects between 380 and 1,000 euros per ton. There's still a quite big price difference due to the different technologies, the different ways to procure energy and this low-grade heat. But we see that there's a strong price point around the 700. This could drop in the medium term. So this average of 700 could drop in the medium term as the technology improves. But we also see a lot of interest for people to use this as a technology due to the extreme long permanence, because the gas is either mineralized and forever underground, or in a gas reservoir where it has been for thousands and hundreds of thousands of years. So it's a very safe way to lock up carbon. Do you have any questions currently around this? So these are the main points I wanted to share today. How does the technology work? Where does all the carbon go? And is it something we can actually plan with? Is it coming to market? And the answer is yes, it's coming to market. But of course, at a price point which is above all the other technologies as of today. Yeah, thanks very much. So this is a really good question. Which companies are investing in direct air capture projects? What we see so far is companies that will create a portfolio. So this is one thing. And they mix direct air capture into the entire portfolio. There are a lot of benefits around direct air capture, but the price point is just so significantly above all the other technologies that it's rarely bought as a single project type. And so far, we see that very large companies go into this, but that's a general trend in carbon credits, and especially manufacturing companies, which are high emitter players, put this into their portfolio as one of the solutions together with others. But so far, I would say large corporates, which are heavy emitters. We also saw that with other companies like Airbus, buying large amounts, Boeing buying large amounts here, and then a few of the leading companies in the carbon removal space, like Microsoft, but also now Amazon is going into this space. In Germany, we saw Audi and H&M as well going in with direct air capture purchases. Demand outweighs supply by up to 3 years. How does balance the scales? Yeah. So looking into the crystal ball is always a tricky thing to do. But what we are seeing is that the total scale up of this entire market, especially around direct air capture, is not in line with what companies expect to buy. So companies expect to buy thousands and hundreds of thousands of credits, but they are rarely willing to invest today already to help these companies grow over time, to then be ready and a sizable market when they actually need it, let's say in 2030, when they want to reach net zero. So therefore, we see a bit of a gap between what companies hope to buy in the net zero year versus how fast the market scales. And this is something we all need to change together, really investing into this market today already with very small purchases to help balance the scale a little bit. Did that help, Stefan? Did I answer your question? Otherwise, happy to take another shot at it. Or are there any other questions right now? Happy to answer more questions. Perfect. Are there any topics you would like to discuss in the next round? Otherwise, we can see what could be a current market topic. We prepared a few ideas we could talk for around what claim can you do with carbon credits today and in the future. We can also discuss topics around direct air capture in more detail, what is behind each of the technology types. We can also discuss other project types, whatever you prefer. So if you like anything, if you are looking for anything in particular, please let me know. And then we can structure a new info series. Perfect. If there's no other questions right now, and I think my video started to work again towards the end, which is great. I hope you enjoyed the series, and I wish you a very nice Thursday. Thank you very much.